Okay, boys and girls, so time for a quick crash course on writing ionic compounds. So the first thing we have to do in order to learn how to write ionic compounds is we have to understand something called oxidation numbers or charges. Now, these, we don't really know yet what they really are, but commit these to memory and it will make sense much later, I promise. So, if we're looking at a periodic table, all of the metals over here in group 1 have a +1 charge, or oxidation number as we call it. All the metals over here in the second column, group 2, have a +2 charge. Sensing a pattern? So right now we're going to skip everything in the middle here. These are the transition metals that we use the Roman numerals for, the 1, the 2, the 3, the 4, etc. So we're not going to worry about those right now. The other ones over here in this group have a +3 charge, and really actually it's only aluminum that we're looking at. The rest of them are transition metals or non-metals or something like that. So we would, in this case, in the carbon group here, they would have a charge of plus or -4, but we're not going to worry about that because they're not really something we're concerned with here. So starting over here with nitrogen's group and everything down, but mostly nitrogen and phosphorus, everything there is -3. We're starting to count down. And then here in the oxygen group, that's -2. And then in the fluorine group right here, that's -1. And then nothing here for these noble gases. They don't have a charge whatsoever. So commit that to memory. We've got +1, +2, and then aluminum over there, +3. And then it starts counting down with nitrogen, -3, -2, -1. And that's when we're putting together ionic compounds so we know their charges. Now, why is that important? Well, that's important because we have to know what the charge is in order to balance the charges out and the compound and everything. So if we look here at something like calcium fluoride, it's important to know what the charges are on each one of these elements. We know calcium's a metal. We know fluoride refers to fluorine, which is a nonmetal. And if we go back and we look at those charges that you remember, calcium has a +2 charge because it's in the second group. Fluorine has a -1 charge. Now, we want those charges to add up to 0 to make a stable compound. So a +2 and a -1 does not add up to 0. We need more minuses, right? In fact, we're going to need 2 of these for every one of these right here, right? So the way we'd write that formula is CaF2, because the 2 -1s from fluorine makes -2, and that cancels out with the +2 from the 1 calcium. All right, and notice in the formula right here, the final formula, I don't write any charges whatsoever. I just use those charges or oxidation numbers to help me figure out what the formula is. So let's go do another example. So let's say we have something like aluminum oxide. So aluminum is Al. Oxide refers to oxygen. We know aluminum is in that area with a +3. We know oxygen's in the area with a -2 charge. This one's a little trickier, so we're like, okay, well, how do we get +3 and -2 to add up to 0? Well, there's a couple different ways. You could look at least common multiple of 3 and 2, which is 6. So let's do that. If we want the positive charge to be 6, we would need 2 aluminums. And if we wanted to be -6 over here, it'd be 3 oxygens. So you see 3 times -2 is -6. 2 times +3 is +6. Positive and -6 adds up to 0. So that would be 2 aluminums and 3 oxygens. Okay? Pretty easy so far. All right? Let's do some more. So let's use one that has a polyatomic ion. So if we have something like sodium sulfate. So we know sodium is Na. You remember sulfate from your polyatomic list, which is SO4 with a -2 charge. That's why you're remembering those charges. Sodium is +1 because it's in that first column. So how many of each do we need? Well, we're going to need 2 sodiums for every 1 sulfate for those charges to add up to 0. So I would write Na2 and then just 1 of the sulfates. And I don't need to put 1 or anything if there is just one of them. But don't forget that SO4, that whole SO4 unit is 1 sulfate. Okay, so don't drop any of those subscripts there. Okay, so let's do another one. Let's say we've got Oh, something like magnesium phosphate. This is one where I'm going to show you about parentheses here. The rule with parentheses in polyatomics. All right. So we know magnesium is Mg, and it has a positive 2 charge because it's in the second column. Phosphate, you guys know, is PO4 with a -3 charge. There's another one where you have a 2 and a 3. We're going to want those charges to add up to 0, so we will need 3 magnesiums and 2 phosphates. Least common multiple of 2 and 3 is 6. Okay, so how do I write this? I go, okay, well, Mg3, and then how do I write 2 phosphates? Well, what I need to do is I need to put PO4 in parentheses, phosphate, and I need 2 of them. So I put that 2 on the outside of the parentheses where phosphate is, just so that I know I need 2 of these PO4s. Okay, so this would be the way to do it. So it's using those oxidation numbers to actually come up with the correct ratio there for your formula. Okay, so this is just to deal with the ionic compounds that are standard. In another video, you'll see how to deal with them if they are in the transition metal area, like iron and zinc and all those in there. All right.